Welcome back to another video, everyone, and in this one we got a little bit of a doozy, all right? But that's no problem, because as long as we know what we are looking for and we know how to extract out the necessary information, we can go ahead and take what seems like a really complicated problem and make sure that we know that our simple steps are going to work for us every single time. But don't worry, it's all good. We got the tie-dye shirt on, we got the iPad fully charged, we got the microphone, we got the camera. Let's get into it. So I'm given that a rectangular pyramid ABCDE, which thankfully is already drawn for us, has a base with dimensions 8 and 5. So that means that this kind of rectangular guy down here is going to have 8 by 5. The vertical height is 10. And O is the center of the base, and it's directly below the apex or the vertex of E. Now, I want to find three different angles. I want to find the angle between the edge BE and the base ABDC of the pyramid, between the edges EB and EC, and the angle of MEMO, where M is the midpoint of AC. Wow, is that kind of a lot? But let's go ahead and we'll just do it one step at a time. So let's focus on the angle between the edge BE, which is going to be this right here, and the base, which is going to be right here. Now, what we want to do is figure out what this angle theta is right there. Now, what we are going to do is extract out the information that we need. So sometimes it's really helpful to draw the triangle that we are talking about. So for instance, if I know that this is going to be E and this is going to be O, I'll go ahead and draw out this degree here. I know this is 90 degrees. Because it's right below the apex, and then B is right here. I know that the height is 10. I want to know theta right there. So the question is, well, how do I solve this, right? And so when we're looking at this, we don't have enough information to use one of our trig ratios. We don't know enough information to use the Pythagorean theorem just yet. So the question is obviously, what do we do? So again, what we want to realize and recognize is that, hey, what is OB? Is there anything that can tell us what OB is? And well, the answer is yes. Because if you think about this, well, this right here is going to be the midpoint, right? O is going directly into the middle of this square. What that means is that OB is going to be half the length of CB by its very nature. And then how can I figure out what CB is? Well, in a very similar way to our last video, we're going to extract out this triangle down here. Because if I go ahead and draw out this triangle as if I'm facing it, what I'll have is I'll have A here, I'll have C here, and I'll have B here. Now I know that AB is 8, and I know that AC is 5. So what is CB? Well, CB is going to be equal to the root of 8 squared plus 5 squared, meaning that CB is going to be the root of 89. Now, the root of 89 is not going to be an easy number to write out, so let's go ahead and keep the root of 89 as our answer for now, so that way we can use the most accurate number in our calculations as possible. So again, OB is just going to be half of CB, kind of by its very nature. So OB is just going to be the root of 89 divided by 2. So now I actually have enough information to solve for the angle of EBO. Okay, that theta that I'm looking for right there. Now, what can I use? Well, I know that this is the angle I am considering, and that is I'm gonna have the opposite, and I'm gonna have the adjacent. So the tangent of my angle is going to be equal to opposite 10 all over adjacent, which is the root of 89 all over 2, meaning that theta is going to be equal to the inverse tangent of 10 all over the root of 89 all over 2. Now the tricky thing here is that you want to make sure that you're putting this into your calculator as correctly as possible. There's a lot of easy ways to kind of mess this up in the calculator. So for me, with the TI Inspire, I always make sure that I'm using this control divide button, so that way I have the numerator and the denominator fields already blank and ready to be populated. But whatever calculator you're using, just make sure that you're being careful with what you put in. And so after you do it in the calculator, which I'll do right now. So I did it here, but I also have it in my iPad Inspire app. And it should look like this. The inverse tangent of 10 over the root of 89, which is all over 2. And if you put that in your calculator correctly and you hit enter, you'll get 64.7468. So again, when we were giving our answer, we are going to write this to three significant figures, which would be 64.7. So theta is going to be equal to 64.7 degrees, and that will be our satisfactory answer for A. So I went ahead and erased the work just to keep this page as clear and simple as possible, but if you need to access that work from before, just rewind the video. So for B, I want to know the angle between the edges EB and EC. So I can see that EB is here and EC is here, so I want to know what this angle is here. Now, what I can go ahead and draw is a triangle just like this to represent the situation. And so I know that I'll have, once I get this thing proper, there we go, C, B, and E. So I know that angle B, in this case, is going to be 64.7. Now I want you to think about something. This is a square-based pyramid. These slant heights are going to be the equal lengths. So that means that this length is equal to this length. Well, then by property of isosceles triangles, this angle and that angle are going to be equal. And that's actually super helpful, because if this is 64.7 and this is 64.7 degrees, well, then angle E is just going to be equal to, so angle E is just going to be equal to 180 minus 2 times 64.7. So now I want to be a little careful here, because again, what I said is that you want to use the most accurate number in your calculations as possible. And what I did here was I basically wrote my answer from A, but remember that I rounded that to 3 significant figures. So if I was to go back into my calculator, I would write 180 minus 2 times my answer. Which would give me 50.5064. So again, the 3 significant figures, that would be 50.5 degrees. So my angle E is going to be equal to 50.5 degrees. Like that. And the reason why I showed you what it looked like in the calculator versus if you did this here is because if you did this calculation, you get 50.6. Close, but not as correct as it could be. So again, you always want to use the actual answer as accurately as possible in your calculations, because you could run into that rounding issue. So again, angle E is going to be 50.5 degrees to 3 significant figures. That one was actually not too bad. So let's go ahead and tackle on C. Okay, so part C is asking me for that angle M between E, M, and O. So I am looking for the angle M between E, M, and O. So that's from E to M to O. So again, just like our last problems, let's go ahead and extract out of that the triangle that we are focused on. So I have a slant height here. I have my height there, and this is going to go over like so. There we go. So I have M here, O here, and E here. Now, do I know what any of these values are? Well, I know that EO is just the height of my pyramid, which is going to be 10. Do I know what MO is? Right here. Well, it's not given to us explicitly, but I actually do know it, because again, the entire length going across from left to right is 8 centimeters. And by its very nature, remember, this ends up as the midpoint. So MO is just going to be half of what it would be to get across the entire side. So if it's 8 centimeters to the other side, well, then MO is just going to be, 4 centimeters. Okay, I know this is a right angle, and I'm looking for this angle here. So do I know enough to solve this? And the answer is absolutely, because I know that I'm given my opposite and my adjacent, so I can use tangent, just like that, which means that theta is going to be equal to the inverse tangent of 10 all over 4. So if I put this into my calculator and go to 3 significant figures, I will get an answer of 59.0 degrees there. Okay, so again, when you're doing a multi-step problem such as this, sometimes it is really helpful to label it more specifically than just theta. So I'm actually going to erase theta, and I'm going to write EMO. EMO. So I know exactly what it is that I'm talking about. So again, labeling as specific as possible. So instead of calling this theta, I can actually go ahead and rename this as, again, this is from E to B to O, and this is that B angle here. So let me write just EBO. So that'll give me what I'm looking for. And as far as angle E is concerned, it might be more helpful to be a little bit specific, because if you were to do this, what if you were finding the angle E there? That's not what you're doing. You're finding it for this entire length here. So let's go ahead and write the other 2 points to make this as specific as possible. So let's go ahead and move the 50.5 over here, and then I'll go ahead and write angle CEB. CEB. Because again, I am going from C to E to B. Okay, so I hope that helped. So even if a problem does look quite intimidating, as long as we can recognize, hey, maybe we have a couple midpoints, maybe we can use the Pythagorean theorem, we can figure out the missing values that we need in order to solve whatever is being asked of us. I hope that helps, and I'll see you all in the next video.